Hello, I am Rakshith Venugopal, a first-year PhD student from the Deutsches Elektron- and Synchrotron in Hamburg. Today we have with us here Nikhil Palekar, Project and Program Manager of Europe from NXP Semiconductors. Thank you very much for accepting the invitation for this interview and for your time. Let's get started.
Thank you, Rakshith.
Yeah. Okay, so for my first question, could you tell us a bit about your role at NXP and what a typical day of yours looks like?
So at NXP, I work for this organization called the Hardware Solutions Competency Center, which is responsible for building ATE test equipment. So that's automated test equipment for the internal business line partners that are responsible for building the chips and end products and also the systems that NXP commercializes with other client companies. So mainly my organization builds the wafer level test and final test hardware, which is mainly required for verification of these chips or these wafers that are produced by NXP. And this is a step which is almost every semiconductor company has to follow because this enables them to ensure that they are only releasing quality products out in the market. And yeah, so the main ultimate goal for them is to verify that each chip behaves the same way as the specifications are, and it shouldn't lead to any issues once it's put into use. So that's in short what my team does. And for me personally, a typical day for me is switching between meetings, following up on status updates with the engineers who work on designing these probe cards, and ultimately, it's the main goal for me is to have a clear and efficient communication between all the stakeholders that are involved, right from the internal business line partners, our team, and the turnkey suppliers who build this for us. So yeah.
Right, that seems really interesting. So, how did you get into this field and what led you to work in this department?
Okay. So my journey started. I would speak a little about from how I started getting into the semiconductor field. I during my last year of bachelor's in 2018 or so, back when I was in Manipal University, Jaipur. I had the opportunity, or I was selected by a PhD scholar back then to work as an associate for with him on a research topic, which was on a microfluidic device, a sensor that we built. And this during my period of work with him, I developed quite some skills in console simulations, which later on enabled me to get the internship opportunity at Texas Instruments when I was at Germany doing my master's. And this internship was really fascinating because it at the end got converted into my thesis project. And so the project was mainly that we built a wafer prober. So a wafer tester is called a wafer prober. And this generally out in the market in other companies, these probers are to be used for dry testing. So basically just to get out the electrical specification or parameters of a particular chip or a device from them. But what we built was something really revolutionary. So we set up the prober in such a way that it could deliver small amounts of fluidic buffers, so pH buffers, right on top of the wafer level without causing any shorts or anything. And this was completely automated. And that's how I was introduced to the world of probers and testers, final test equipment, wafer test equipment. And after my thesis, fortunately, there was an opening at NXP, which completely aligned with what my thesis project was. But only the catch was that it was a project management position and not a technical position, which was fine for me because getting into the field of program manager was also had a personal side to it because my father started his journey, his career in project management. So that's what motivated me to get into this field, and pretty far I'm enjoying it so far.
That's really interesting. That's really interesting for me to hear about your journey.
Mhm.
Okay, so moving on. Another question. So when a chip passes through the test equipment you help deliver, how close is it to end up in something like a smartphone or an electric vehicle?
Mhm. That's a good question, Rakshit. So, when a chip is fabricated and this is released for testing, so when it comes through our prober equipment, they are right at the end of the quality cycle. So, uh, the testers enable them to verify these chips, and that, as I said, that they should behave as expected and should not have any glitches or any issues, which may come due to all kinds of reasons. As you know, semiconductor devices are highly sensitive to ESD damage, or some debris from ambient atmosphere could reach in and create a short, which ultimately release to a end product, may lead to life-threatening issues or somewhat. So, so right after the testing is completed, these chips that are so let's go from the wafer level test. So at the wafer, each die or some of the dies will be verified to check if the manufacturing recipe was intact and there are no issues across the wafers. And after this, there is a packaging procedure. So packaging procedures are more expensive than the testing equipment or the testing procedure itself. And if you were to not do the wafer test and release it directly for packaging, this could lead to the bad devices getting packaged, and this can cost the company a lot. So that's why the wafer test is very important and followed. And to ensure that even the packaging procedure was correct, the final test comes into play, which is done after the packaging. So once this is complete, the whole package, we deliver the devices to the end customer, which can be an automotive company or a smartphone company, which directly installs such a chip in the smartphone, and you get it as a end product.
I see. So with this automated test equipment, do you test the dies till failure, or is it a type of stress test you do, or is it a preliminary test to just check, as you said, if everything's working properly? Or
It completely depends on the device itself, Rakshit. So, let's say, the projects I handle are mostly in the department in market segments of automotive radar sensing, so sensors. Then there is secure ID products, which are used in banking cards, and also if you know, NFC is also a product of NXP, and this is also so. If it's a micro electromechanical device, that has to go through a stress test and other mechanical forces. But in our case, we don't do that. The main procedure for us to ensure to test the main parameter we are interested is in to ensure that the electrical specifications are met. And if you take a look at any IC and its data sheet, then you'll find a lot of information about stress test, mechanical tests, electrical tests. So us being a core semiconductor company, for us, it's important to know that our procedures have not been hampered in any way. So only the electrical parameters are ensured that they are working correctly. And once these are handed over to the end customer, and they can build on it with other mechanics, and then it's up to them to take the test forward.
I see, that's really interesting. Thank you, Nikhil. So when you complete a project, what does success look like for you?
Okay. So whenever a project is completed, I make it a point that I try to make down a list of uh, what what things went wrong, what things went right, and ultimately for me, success is basically we need to evolve, right? So we need to ensure that the past lessons learned are implemented correctly, and there were no surprises that came into play, but during the life cycle of that project. Moreover, for a project manager, the most important thing is that the we call it the holy trinity. That's the that a product needs to be delivered on time. It should be in the budget and should have the utmost quality. But apart from that, for me personally, if all the stakeholders or the people involved in a particular project are aligned together and on the same page, and there are no miscommunications happening, then for me it's a successful project, and that's how I define it. So yeah.
Well said, Nikhil. Thank you. So I would like to get into what kind of technical backgrounds would be most useful in a role like yours. And do you think a person needs really deep engineering expertise to succeed in this type of project leadership role?
um I would say, so for me personally, and up until the time I got the opportunity to get into project management, I did not look at any other or seeking expertise in any other domain. So my focus had always been core technical, and that's why I had my experience up until NXP was completely technical. But I would say, if for the next generation coming up, I would say it's really important that you focus on the core technicalities as well, because that enables you to understand what happens at the factory level or at the core of every semiconductor company, let's say. And being said that, it's also important that you also get an understanding of how multiple fields come into play. So hardware, software, and material sciences, physics, for example. Everything. So the semiconductor industry does not work in silos. It's a cross interdisciplinary field. And being said that, you can never lose focus of the other stuff, right? Like the soft skills. So improving your soft skills, presentation skills, these things together, I think, really build you for a role in leadership. So for me, even though on a day-to-day basis, I don't have to use my core technical knowledge, we have experts for that, but still it really helps that you are able to understand the problems or the things that go right, and you're able to communicate this correctly to the stakeholders who are involved in this project. So yeah.
Soft skills combined with hard engineering expertise would make a deadly combination.
Absolutely.
All right, so moving on to the next question. This one I would like to ask would be, how would you describe the current state of the semiconductor industry in Europe? And what do you see as Europe's strengths and challenges in competing globally, especially with countries like the USA or with Asia as a whole?
Okay. The way I see it, the semiconductor industry in Europe right now is in a mixed state. So, on one hand, there are strong strategic momentums driven by the EU government to boost, or the target was to double its global chip market share by 2030. Uh, but on the other hand, the region is facing real challenges in keeping up pace with with, let's say, Americas or the Asia, especially in high growth areas like AI and advanced logic manufacturing that's happening right now, as you know. So in the past year, so the last quarter of 24 and early 25, Europe experienced a significant market contraction. And this was largely due to post-pandemic overstocking, as we call it, and weaker demands in key sectors like automotives. While global markets have rebounded mainly because of AI and the data center demands in Americas and in Asia, Europe is lagging behind because the focus is mainly on automotive electronics and power electronics, or say. But that is also Europe's strength, the expertise in analog, power electronics, and automotive grade silicon. So that's where they are really having quality products and reliable. Uh, that's why there are many companies like NXP, ST Microelectronics, Renesas, and so on that are working towards this. And I would say this is it's a ever it's a dynamic field. What we're facing now will be completely different in 2 years timeline. So yeah, that's my take on the global market of semiconductors so far.
Thank you, thank you. That's really insightful. Europe being leading in some places and lacking in others, you think that there's space to grow and space to keep ahead.
Exactly.
Mhm. Thank you, thank you. So, so to the next generation of young people who wish to enter this field, what kind of advice would you give them?
Okay, my advice would be curious, be adaptable, and don't be afraid to get your hands dirty with real world projects. This industry is incredibly dynamic. It blends deep technical knowledge with global collaboration and touches nearly every aspect of modern life. So, from smartphones to electric vehicles, autonomous vehicles, and your secure IDs. I would say start by building a strong foundation in fields like electronics engineering, physics, computer science, and so on. But also explore areas like system thinking, data analysis, material sciences, and also project management. Since I, because success in this field often comes from being able to connect the dots across disciplines. Uh, so ultimately, I will say stay open to learning. The technology evolves fast, and the best people in this field are the ones who never stop asking the right questions.
Thank you. That's really insightful. Staying on this topic, from your perspective as a project manager, what challenges do you see for women entering or advancing in the semiconductor industry? And do you think if the visibility of women in leadership or technical roles influence the career choice of younger students?
That's a good question, Rakshit. So I think, yeah, NXP supports gender diversity and initiatives in developing female talent. But I would say there still seems to be a low number of female employees in such a highly technical industry and a company like NXP. I would say this is probably because many girls don't see or idolize a lot of women in such roles, which makes them have self doubts. But this is definitely changing now. There are many, the new generation women coming up and taking on the technical roles, reaching leadership positions by the time the further next generation females have someone to look up to. And I personally know many talented female employees who are excelling in their technical fields now, also serving to be role models for the upcoming generation. So for many women, I think it's important that they have a focus on the core competencies, like the technological core fields. At the same time, the strength, right? So they should focus on also good communication and creative technical presentation skills. Also tend to be growing their influence in impactful managerial positions in NXP.
Thank you.
Mhm.
So, if you want to add something to that, for example, if you're speaking to a young woman right now studying physics or engineering or management, what
Mhm.
more could you say to encourage her to consider a career in the sector?
Yeah, I would say no matter how boring it gets, focus on the technical part because once you put your feet in the out there in the market and the industries, then you would know where such information is put into use and how things multiple things come into play and build a beautiful product like a smartphone, for example. And yeah, so I would say they should focus on also the recent technologies around us, gather all the information that you can, and I don't know, like focus on problem-solving skills and have an innovational mindset. So basically, this field not only gives a very vast learning platform, but also inculcates, it should inculcate in all of us a sense of responsibility towards the future of technology, let's say.
Thank you. Thank you. So for students, are there any initiatives between NXP and other universities? And are thesis opportunities and internships covered by NXP?
Yeah, so about that, I wouldn't say there's an official initiative as such, which has a name that NXP has tie up with other universities, but they do have a lots of, or NXP does take participates in lots of job fairs across universities. I personally know a few friends who have attended every year at TUHH for the fairs. And we have many students working at NXP on several thesis projects. Uh, so yeah, that keeps happening. So I would say keep applying to NXP, and you would definitely get a really good thesis opportunity eventually.
Thank you. Thank you. I'm pretty sure many students who would listen to this interview would love to apply to
Mhm.
NXP. And for my last question, how do you think academia can better prepare students for entry into the semiconductor industry?
Yeah. So speaking from experience, I would say there are 3 points that come to my mind. So first, there's a need for more hands-on application-oriented learning. At the university level, what we learn is theoretical, and it's really difficult for us to imagine how many of the principles or things that we just answer in our exams come into play in the real world. The semiconductor industry is very practical, so students really need to take benefits from the real world problems, and that's why I would say uh, taking uh, taking up internship opportunities or something from several industry-based companies should really help build on that. My own thesis experience at Texas Instruments really prepared me for the job role that I am currently working on. And yeah, so secondly, interdisciplinary training is key. The industry doesn't operate in silos. Understanding how hardware, software, all of these fields come together is incredibly valuable. Here, academia can support this by offering more cross-functional courses and encouraging collaboration across departments, which you do have in most German universities, as I see. Then, thirdly, I would say focus on your soft skills. That's going to develop you as a leader, and for later on in your life, to when you get into fields like project management, communication, and teamwork is key. uh, yeah, it's not only the technical knowledge that's important, but also soft skills. And, and yeah, so finally, the stronger industry academia partnerships are highly essential, I would say. Attend guest lectures, mentorship programs, and co-develop coursework can help bridge the gap between theory and practice. And that should be the main goal, to bridge the gap between theory and practice. So yeah.
Thank you. Thank you very much, Nikhil. This was a really wonderful interview. Thank you so much for your time. I'm really positive that this interview will have a great insight into the industry and will inspire many students and talents. Thank you very much again,
Thank you
and
so much.
have a great day, Nikhil.
You too. Right.